Hi. For VIDL video project, I'm going to share my research with you. I've been working on this for the past year for my master's thesis, and it has to do with artificial intelligence and reinforcement learning in particular. What my work involves essentially is simulating a physical system and looking out for any catastrophic failures that might occur, and then using artificial intelligence to find out a way to recover from them as soon as possible, so the human operator doesn't have to work too hard or push too many buttons. So what I'm showing you here is a model of a fuel tank system in a cargo plane. So there are 6 tanks, 1, 2, left auxiliary, right auxiliary, 3, and 4. And the graph you see at the bottom is just a representation of the imbalance between the left and the right hand tanks. So the higher up it is, the closer to 0 it is, the better. So first we're going to simulate the system without any AI working on behalf of us. So let's go ahead and hit start. So immediately you can see that tank 4 has developed a leak and its lever is the lowest in there. And that is what we want to recover from. You can see that other tanks are also emptying, and the imbalance as they empty out is approaching 0, but it's not approaching 0 fast enough. And that is what we want to avoid. We want to increase the speed at which the system recovers from a fault. So we're going to run this system again, but now we're going to use the AI that I introduced before. So the system is first going to learn its environment, and it's going to so the numbers you see on the screen are just the AI learning its environment and fine-tuning the parameters that represent the cost of taking different actions in the environment, so it takes the most beneficial action that it sees. The learning process is periodic, so depending on some number that I provided it's learning that environment again, because I'm assuming that the system changes over time very quickly, so we cannot rely on a previously learned function to act on our behalf time after time. And there you go. So this rapid jump, this rapid decrease in imbalance is what we are going after, a very quick recovery from a fault. And we want it to be fast enough so the system can recover, but we also do not want it to take too much computation time that it defeats the whole purpose of introducing an AI. So here you can see that it's very quickly approaching 0 compared to the simulation we last ran without the AI. So you can see that in the system with the AI, it took us just about 6 steps to get within less than 1 units of 0 imbalance. But in a system without the AI, it took us about 25 or 26 units of time to reach the same performance. So the system with the AI was about 4 times as fast in recovering from a fault. And by changing parameters, we can make it even faster. So that is what I've been working on for the past year. Mostly it's just glorified number punching and code writing. Yep. Exciting work.